In this video, we're going to be finding the limit of a rational function. And for this function, finding the limit is going to involve some tricky factoring. So the limit we're going to be taking a look at is the limit as x approaches -2. The numerator, we're going to have 1 over x plus 1/2. And in the denominator, we have x cubed plus 8. So just looking at this, as x gets close to -2, this term gets close to -1/2. Add 1/2 to that, and in the numerator you're going to get 0. And as in the denominator, as x gets close to -2, this is going to get close to -8. Add 8 to that and you'll get 0, so we have a 0 over 0 indeterminate form. Indeterminate form. So that means we have more algebra to do to either find the limit or conclude that it doesn't exist. So what are we going to do here? Well, hopefully you recognize that this x cubed minus 8 bears the form a cubed plus b cubed. If you remember from, I think it was algebra 2, that this is a plus b times a squared minus ab plus b squared. And if you don't believe me, I'll just go ahead and expand this out to convince you of that. So we have a times a squared is a cubed. A times negative ab is negative a squared b. A times b squared is positive ab squared. Now we're working with the plus b term here and expanding that. B times a squared is plus a squared b. B times negative ab is minus ab squared. And b times positive b squared is plus b cubed. So we have a plus a squared b term and a minus a squared b term, so these terms cancel. We have a plus ab squared term and a minus ab squared term, so these terms cancel. So we have a cubed plus b cubed. So a cubed plus b cubed can be factored into a plus b times a squared minus ab plus b squared. In this case, your a is x and your b is 2, because 2 is the cube root of 8, or 2 cubed equals 8, since 8 is 2 times 2 times 2. So this limit here, it's going to proceed here, it's equal to the limit as x approaches -2 of 1 over x plus 1/2 divided by x plus 2, that's the a plus b part, times x squared minus 2x. The minus 2x is the a times b, so minus x times 2 plus 2 squared, so b squared will be 4 in this case. And this is just an aside here, so might as well circle that. And we want to get this numerator here written under a common denominator. So to do that, we'll multiply both terms by, we'll multiply this term by 2 over 2 and this term by x over x. So 1 over x times 2 over 2 is going to be 2 times 1, or sorry, 1 over 2 times 1 over x is going to be 2 times 1. 2 over 2 times 1 over x is 2 times 1 divided by 2 times x. And that'll be added to 1/2 times x times x. So x times x times 1/2. And this is just so that we can have a common denominator of 2x for the numerator of this complex fraction. And in the denominator of the complex fraction, we still have x plus 2 times x squared minus 2x plus 4. Okay, so this can be simplified to the limit as x approaches -2 of 2 plus x divided by 2x. That's this part, the numerator. In the denominator we have x plus 2 times x squared minus 2x plus 4. Okay, so this is the same thing as the limit as x tends to -2 of, I'll just write this 2 plus x as x plus 2 over 2x. And remember, dividing is the same thing as multiplying by the reciprocal. So this is the same thing as multiplying by 1 over x plus 2 times x squared minus 2x plus 4. And what you'll notice is that x plus 2 and x plus 2 cancel, and we're concerned with the area around where x equals -2, not at -2 itself, so we don't have to worry about division by 0. We're only concerned as x gets really close to -2 from both above and below, so like -2.0001 and -1.9999. Anyway, this is the limit as x approaches -2 of 1 over, so all we have left here is 2x times x squared minus 2x plus 4. So as x gets really close to -2, this 2x term here is going to get really close to -4. X squared is going to get really close to -2 squared. Minus 2x is going to be approaching -2 times -2. Then we just have a plus 4. Close parenthesis. So this is 1 over -4 times -2 squared is 4. -2 times -2 is 4. So -4 times 4 plus 4 plus 4. And that is -1 over 4 times 12, which is 48. So we started out with what was an indeterminate form, 0 over 0. We factored this denominator, rewrote the numerator over a common denominator by multiplying this term by 2 over 2, this term by x over x. Both convenient forms of 1 that would allow us to put the numerator over a common denominator. And that's the numerator of this complex fraction here. And then we rewrote this as the reciprocal. We said dividing is the same thing as multiplying by the reciprocal. We were able to cancel out this problematic x plus 2 term. We're left with this limit. We evaluated it and got negative 1 over 48.